Hey everyone, my name is Gunjan. I'm a cloud architect in developer relations team at Palo Alto Networks. And I've been working on containers, Kubernetes for last 4 years as a developer advocate, architect, etc. So, a show of hands, how many of you have played around with Kubernetes? Oh wow, all right, that's about 80%. So I don't need to explain what a pod is, but what I'm gonna do is try to explain you in 5 minutes how a pod is born and how it dies. So let's get to it. For those who don't know, pod, it's not an AirPod. In Kubernetes, it's a basic building block of how things are deployed, right? In a pod, there's multiple related containers, related here being the keyword. They all share, all the containers in a pod share a network namespace. So they'll have the same IP address, containers within a pod. So kind of looks like this. Pod is the orange box and containers are the blue and the blue containers. So for pod has a field, pod object in Kubernetes is called status, and it has a subfield called phase. So the state diagram for that kind of looks like this. So when you schedule a pod, it starts with pending pending phase, and then it could go into any of these 4 phases. So we'll see how that happens. So this is pods live from 9,000 feet. I have a short version of the long version of this talk, webinar bit.ly/CNI-video, where I talk about how CNI works and how pod is scheduled. But in this one, you have your developer. Developer has kubectl, a CLI tool plus kubeconfig. You do a kubectl create, and you create a deployment, which triggers a pod. Let's say for simplicity purpose, it's a pod, you're creating a pod. It goes to Kubernetes API server, which is a control plane component. Next thing the API server will do, API server does a bunch of things internally, but after all the validations, it will store this into etcd. Etcd is a key value data store. And the other components as part of the Kubernetes control plane are scheduler and controller manager. So it writes it to etcd. If that succeeds, it will send back success. So if you get kubectl error, that happens during this phase. After that's done, scheduler and controller manager are constantly watching for new objects. Whenever there's a new pod created, scheduler picks it up, and scheduler will tie it to a node. This node has this much CPU left, so I'm going to schedule it on this node. So after that's bound, on your node, you have kubelet, you have your Docker daemon or CRI-based container runtime, CNI, and kubeproxy. So kubelet is watching. Kubelet sees that, okay, I have a pod to schedule. What it will do is it will create a pod network namespace. Then it will talk to Docker daemon or container runtime. And that container runtime will create containers inside it. We'll zoom into this a little bit more later. Then it will send an add command to CNI. CNI will then network the pod, assign an IP address, and make sure it can communicate with all the other pods. Kubelet then says, okay, success, it's scheduled. And then kubeproxy picks it up and it will manipulate IP tables or IPVS and add this pod as an endpoint in a service. And then finally, controller manager gets updated saying, okay, it's done. I have a new replica of this deployment. This is kind of how the state diagram looks like. Since I don't have much time, I'll make the slides available for later. This is an interesting one. With Kubernetes, you have a concept of init containers. You can have a container that initializes the pod. So when you start a container, init container starts first. After that's done, then your main container, main application container starts. Kubernetes also has something called post start hooks. Those run here as well as